Hello, everyone. My name's Simon Taylor. I'm a Senior Vice President at Zool, and I'll be taking you through the topic today. Just waiting for some additional people to join. So welcome, and we'll be starting shortly. For those that are just joining, hi, my name's Simon Taylor. I'll be working through the presentation today and the webinar. We're just waiting for a few more people to join, so just bear with us another 30 seconds, and then we'll start. Okay, let's make a start. Hi, everyone. Great to have you joining this webinar today. And it's a very exciting topic that we'll be talking about. So first of all, I'm Simon Taylor. I run all of the channel at Azure, but I've got a wealth of experience in different areas. And one of those is AI, particularly as it relates to things like e-commerce, machine learning, things like that. So I'm going to relate that to my other experience, which is also in ITAM, IT Asset Management. We're going to have a really interesting conversation today, which is all about how AI is shaping and helping in IT asset management. And lots of different conversations we're going to have. I hope you like the lead in here. We're very much a James Bond type of theme, but we're going to be talking about really what's shaping the industry in AI, what types of AI there are specifically, and just get everybody's a little bit more focused in those areas. What role AI is now playing in ITAM and some of the challenges that organizations are facing. And then because Java is one of the biggest issues that people have some concerns around with AI in general, particularly as large scale, what's called operational AI or narrow AI focus, things that are more transformative in the AI world, and the models that are built have significant Java underpinnings. From a licensing point of view, there's a lot of concern about scale. So as you start to grow your AI environment, what does that mean? So we're going to talk about that as well. There's going to be plenty of opportunities to ask questions at the end, or you can please use the chat all the way through this. And I've got my able assistant here, Stephanie, who's going to help me all the way through this. So first things first, let's talk about what AI means for you. And of course, it means lots of different things, everything from how your car is learning to drive itself, or is, if you've got an electric car, the range you can get from the charge and what that means in terms of different driving conditions. That's a type of AI. To coming out with predictions on forecasted patterns of weather, and what that's going to look like for both the next few weeks and the weekends. That's a type of AI. Another type of AI is more machine learning. So when you're looking for very much classification or categorization of how data is managed, and you're really looking for more intuitive insights or prediction or recommendation, that's a type of AI. But rather than me sort of really put this in your head, what I thought we would do is just have a quick poll. So we're going to put a poll out to you right now. And the topic is, how do you think about AI and driving success with an AI project? So Stephanie, if you can bring up a quick poll for me, that'd be great. Coming up at all, Stephen? There we go. So you've got 6 options. Please stick as many as you see fit. And as we go through all of these, we'll share some of the results. But there's some really sort of interesting area topics here, and there's some that are obviously very simple, like for instance, managing cost, which is about licensing. So have a think about this, ask some few questions, let me know what you think. I'm going to put my own answers in as well, because I think it's a bit about improving a process, for example. So have a quick look, wait another 20 seconds. Okay, and then I'll hit submit. Okay, so I don't know whether there's any results that show back on that, Stephanie, at all. There we go. So by far, a lot of people are thinking about it, about enhancing a productivity and process, which is great because we're going to talk a lot about that. Some people think about it as the AI model itself and how it learns and what does that actually mean. Often called learning management technology or LLMs. Quite a few people said obviously managing cost, which is the ITAM piece of this conversation, and then the rest of it is a little bit more technical as well. But even down to, how do you get data? I mean, you can't train an AI model unless you get good, clean data, and that becomes a limiting factor in a lot of the AI processes here. So great feedback, thanks very much. Okay, let's make a start on the next slide here. So what do people know today? You probably know generative AI or Gen AI because you're busy using that with ChatGPT, OpenAI solutions. And that's one type of AI. In many instances, that's the most popular, and it's probably one of the most exciting types of AI because you can see some real material value as you as an individual with productivity, things like that. It can learn the modeling behind it, an agent-based model, so it learns very specific types of content and context. You're going to hear about that word a lot in AI, is context. So data is one thing, and where the way something learns is important as well, and the technology you're using, but the context gives it almost like a methodology about the way AI can answer questions. So for example, I was at an event just recently, and to illustrate the example is think of children. So if you're asking your children, what would you like for dinner, right? You're going to get a range of answers, probably 50 different answers of things they would like. If you say to them, would you like pizza or would you like salad? Well, obviously, most kids will go for pizza, but you've narrowed the context. You've made it much easier for them to answer within a realm of possibility. AI is like that as well. So when you're building AI models, you obviously want to supply context that is relevant to the type of data, but you don't want to blow it into something that's too complicated. And that's where you see a lot of Gen AI technology today, which is some of the contexts are very big, some of them are small, some of them are narrow, and you see a lot of things working well or not working so well based on that. So other good examples of generative AI that you can think about and apply in that context are things like, generating articles, social media posts. I use it myself every single day for something, whether it's helping me write a little lyric in a birthday card for a family member, or it's looking and researching some topics that I'm really looking at trying to get some interesting insights onto. You can even use it to generate artwork and things like that. A lot of people use particular generative AI solutions in that area. But it's very focused and related to solving a particular like content creation task primarily. Now, in contrast, there are other types of AI. So you may have heard of something called narrow AI, out of general AI and superintelligence AI. So not many people understand superintelligence AI. That's the one that takes over the world and it becomes Terminator very rapidly. Narrow AI intelligence is very much the one that we think about when we're trying to solve a task or process. So when I asked you that poll earlier on and everybody was saying, oh yeah, I want to see a particular productivity outcome, or I want to try and solve a particular problem, most people are implementing narrow AI solutions. And that's predominantly the model that powers a lot of business as well. So that could be add to cart if you're an e-commerce company. So one of the biggest challenges is when you're interested in buying something, whether it's Amazon or whichever merchandising environment you go on, it's by no magical happening that all of a sudden you get 15 different recommendations of other things that you can buy. There's an AI engine recommendation sitting there in the background, tracking other people's signals and traffic, and is then orientating that to the most appropriate recommendations for you based on your own buying patterns. That's a very narrow AI solution sitting in the background there. If it was paired up with some virtual assistant that was trying to take all of your voice recognition patterns, maybe some of your sentiment, the way you're feeling, things like that, and then relate that to buying patterns, that would be generative AI coming into a narrow AI existence. So you sort of get the two worlds colliding a bit. Now, in general intelligence, that's where we're starting to resolve things. Now, you could argue that some types of, they're called agent AI solutions that robots are using today, they are getting to that point where they are able to make decisions by themselves. As a self-driving car is a form of general intelligence because it's making decisions all its time. That's not something you necessarily see in the business world. It's more in the human world where we are interacting with a machine or something. But you can see where the direction this is going in. But most of these are powered by some form of learning model underneath. And again, data inputs are really key. So a car doesn't drive itself. It has a ton of cameras all around it. It's looking at its driving patterns, how much your battery's charged, things like that, street patterns, GPS satellite navigation, stuff like that. All inputs coming in to improve that learning model. Anyway, without getting into too much of a direction here, operational AI is where we're going to focus a lot today because that really is the mainstay of what businesses think about in terms of solving large process tasks issues. So practical uses here are everything like fraud detection. How do people detect patterns of a credit card fraud or things that relate to processes that relate to that? They have to really analyze billions of transactions today and look for patterns. That's a machine learning process. That's operational AI. Customer service automation as well. How do you self-serve people that are coming to your website versus picking up the phone and speaking to a call center? And it's because you're offering suggestions to them based on the problems that they have. And a good example, if you have a vacuum cleaner, you can probably self-solve most of the issues with a vacuum cleaner just by going to the manufacturer's website and putting a few questions in, because it's generally routine maintenance that breaks those things. Now, there's a type of AI behind that's offering up recommendations to solve your problem so that you can avoid interacting with a human, and which costs time. Um, Things like cloud pricing optimization is another one. If you've moved your applications to the cloud, how do you optimize for that? What patterns are you looking at? Everybody knows in e-commerce, Black Friday time of the year, particularly in the US, you can expect e-commerce volumes to double, if not triple. So how do you manage those patterns and optimize your cost base? That's like a type of AI as well. Hope you're staying with me as we go through this. Now, this is a little bit just as a quick sort of refresh on how these conversations relate to each other. So the overarching principle of AI is the highest level. Then you get disciplines within it. So machine learning is a way of automating types of AI based on a particular algorithm. So you get data in, it learns from that data, then you apply a particular set of algorithms against it. You're looking for classification, categorization. Good example would be you have a whole bunch of random data and you want it to automatically understand all of the different filing categories for that data, like a taxonomy, or what type of unstructured type of relationships occur within that content. You run a machine learning algorithm against that and you get some out. Other types is deep learning, where you're going to dive a lot more into the detail. That's typically what happens with data life sciences. And a good example is COVID. Part of our COVID research, when that first came out, wasn't just distribution patterns of COVID, but it was relating distribution. So, for example, people were self declaring their COVID status on their iPhone. You look for distribution patterns, but you also want to look at the demographics of that individual age group. Do they have any prehistory or medical condition, things like that? That's now diving into different types of data and relating it to other types of data, which is deep learning. Then you've got learning types and machine learning, which is supervised, unsupervised. So for those that know, that's, as the name suggests, supervised is where a human has to put something in there, unsupervised, where it sort of self-learns. And then that's where you start to get generative AI, which comes together as a multifaceted discipline here, where you've got a self-learning model with some deep learning validity with a particular context, and as a result can generate some really interesting use cases. And then I've just summarized here a little bit about neural networks and things like that, just because these are more advanced topics. But it gives you an idea of how these things relate to each other just at a high level. Okay, so how do models learn? Well, it's super easy. And again, I'm not going to get into a lot of detail on this webinar, because it's more about just giving you the high level so we can relate that to the context of ITAM. But you need data. You need to train an AI model based on data. So you have raw input data. Then you have to understand and know how to interpret it. And a lot of times you may not have a context, so context is key. So then you apply the algorithm against the context. So it's the scope. That would be a machine learning algorithm. You do some processing, and then what you end up with is much more structured, trained output. So a good example is you might have a lot of random data, which is vegetables, fruits, all sorts of stuff like that, but you don't know what it relates to at that point. And the output is you've got everything classified by type of fruit, how many apples you have, how often those apples occur, when do apples and bananas ship at the same time. All that type of thing would be trained data that you can then ask questions of it and say, what time of year is the best time for me to ship bananas in North America? And it would tell you, because you've trained the data model to be able to do that type of thing. Silly example. So that's the theory. Let's talk about some headwinds here into getting AI savvy, because as it relates to ITAM, there are some really important topical areas to consider. The first thing is defining business goals. So a number of you said that the goal you had up front was to actually solve a particular task or process or improve it. And that would be a driver. So setting that goal is key. So do you want to achieve a 20%, 30% improvement in productivity? Do you want to solve your supply chain and make it run 50% more efficient? Is that a goal? But then you have to think about the other teams that you're interacting with. So AI isn't a magic button. You don't just press go and it all sorts of comes together. You need data scientists, you need AI specialists, and you need to define exactly what you want them to do, because a lot of data scientists will build huge models with massive contexts, which means that it becomes very challenging to get an answer. And a few years ago, a very big vendor that you may be aware of tried to do something similar for healthcare. And it was very challenging because the model was huge and very cumbersome, and you couldn't get a lot of answers very quickly. So it pared down into very much more contextual, smaller models that drive better outcomes. And then, of course, there's the IT team. Why is the IT team important? Because they have to implement this stuff, right? So they need to know where it's going and the licensing and the scale and everything that's associated with it. Most importantly, things like power and cooling. A lot of people grow out of their ability to be able to support AI because maybe it's in a traditional data center. You don't have enough compute, and therefore you don't have enough power either. So there are some headwinds, and these headwinds are business leaders need to define context and scope, data scientists need to minimize complexity, and IT teams need to reduce cost and manage licensing and scale as much as possible to create efficiency. So what does that mean? So in the context of ITAM, as we're progressing here, there are probably today about 6 core issues that relate to the future of ITAM. One of them is, how do I get complete visibility of a set of assets related to a licensing challenge? And that could be things like, in my world, Java licensing. It could be stuff to do with licensing of your desktops. It could be to do with cloud licensing. Then, of course, the challenge is then tracking usage. And I don't mean just what's installed. I mean, what actually is being used, because most of your licensing challenges are not to do with how much is installed. It's actually, what are you using? You can accidentally install something and it becomes a potential licensing obligation, but really it isn't. If you're not using it, then you could just delete it and it's not really relevant. Then there's compliance. If you have agreed thresholds of licensing with particular vendors, how do you stay in and out of compliance? You need to understand that. Or you've agreed not to use a certain vendor's licensing because you're using somebody else's. How do you make sure that none of that creeps into your environment? These are challenges that AI can help with. Security is a big one. Nobody knows necessarily where risks are until it's too late. You have a breach, you're then having to do an incident response, you're having to remediate, and of course you don't know whether it was something that came in through, say, third-party libraries or open source versus the products that you know are well managed and have secure security models around them. Complex processes, another area, just sifting through the detail. And then probably one of the biggest areas is just diverse sources of data. I mean, cloud, on-premise, data center, different environments, different software packages, different types of infrastructure, all of this data across your organization. How do you get insights? How does it become of value to you? So the good news is there is actually help here. So AI can help you in a number of areas. So if you pick each one of these and just break it down, and you can get copies of these slides from us if you follow up at the end of this the talk as well. But you can use AI to take all of the scanning information and then look and provide a comprehensive view. So in other words, remember that model with the fruit and how we then classified it by types of fruit, how often fruit comes in of the organization, things like that. You can use AI to give you that type of insight. That's machine learning running against all of your data assets, looking for patterns and trends, right? You can look for inconsistencies. So why have I got this type of licensing when that department shouldn't be using it, when this is the department over here that should be using that type of licensing? That you can get that type of infrastructure. Why have I got 5 times more licensing for the same product in the cloud when I'm not really using that product in the cloud? Stuff like that. You can get much more insights that way. Slightly more analytics, but relevant. Then you can get real-time monitoring and then get alerts and things with that. So one of the big things with compliance is what's happening where, how do I get alerts, what do I do about it, what's the set of recommendations, where do I need to remediate? AI can help you understand, and you can start asking questions. Where is my biggest compliance risk right now? Well, I'm sorry, it's in South America or somewhere, so and that could be the issue you go and address. Fourth thing is identifying areas where you don't need license, or you could actually proactively get rid of stuff. So this is super interesting, because imagine you've got a large amount of licensing volume and you're only using 1/3 of it. Why would you even license the other 60% if you're never actually using it? right? But you don't know unless you can start integrating and get insights for all of that data. And then you can see the other one, complicated tasks, just repeating some of the conversations we had in the previous slide, but also the analysis across diverse sources, bringing data together, which is complex and diverse. So unstructured, semi-structured, structured data. AI, depending on the model, is really good at sort of integrating different types of data sets, cleaning it up in that ETL type of process, transformation process, and then applying good understandings and insights against that with machine learning algorithms. Okay, so first and foremost, what would be the headline banner that I would consider as the most important thing on ITAM? It's probably predictive insights. How can I analyze my patterns of usage today, my constraints, my compliance, and what I need to do moving forward, right? Can it help me predict how I can save money, how I can optimize, how I can identify underusing assets, and really better manage my overall estate? Now, of course, following on ITAM predictive insights, there are a number of key technologies that sit inside the model that this supports. If we go a step further and we start looking into what these technologies are, the first one is natural language processing. Now, natural language processing is just a way that you can take voice and associate it with text that can in turn go off and execute a search or gain insight that can resultantly come back with a response, whether that's in text or verbal form. So as a result of implementing a natural language engine, you could actually detect sentiment. So you could detect how people feel. And a very good example is maybe if you call a call center and you're frustrated with your telco provider for your cell phone and you're about to ditch them and go to a different provider, that provider could detect how frustrated you are and maybe offer you some additional incentives to stay with them automatically as part of your experience of using that type of AI. Machine learning, we'll talk a little bit more about in a second, but that's a very specific type of technology that really is looking for patterns so it can make predictions, look at for insights. It requires a lot of training, a lot of context to make it work, but those algorithms run and they're looking for very specific things so that you can look for or create very specific patterns of engagement. Computer vision is sort of the same, but instead of in text, it's more picture orientated. So you're looking for similarities in pictures, recognition, looking for deep learning. A good example would be using video surveillance at an airport, and you're screening obviously all the pictures and the vision of individual headshots, and you're looking for a particular type of risk. It can be used in self-driving cars as well to identify where individuals are in the road by just using cameras to identify a human being, for example, from something that's more of a static object. And then finally, deep learning uses neural networks to get into much more embedded pathways. If you imagine, I often think about it as like a mine shaft. So you're going down a scope of data, but then you go laterally across all the connections that data can have, just to make sure that you can really truly connect other types of insights together in a way that probably weren't relevant. A good example again would be COVID, where you go into particular COVID dispersion patterns, but then you start looking at other types of demographic on individual, age where they were born, authenticity, things like that, and really start to truly explore the nature of the data so that you can look for other types of information. Now, if we focus specifically on machine learning, this is the one that's probably more relevant just from a technology point of view. Machine learning has a very clear definition, and it's about understanding how it fits into artificial intelligence as a whole, but it's what it's intended to do, which is to learn from data, identify predictions of patterns of data, and do that based on algorithms with minimum human intervention. So good examples are looking for the latest drug development, clinical trial, for example, where you're taking all the data of someone trialing a drug and the way that that's being approached in the market, and then you're analyzing all that data and pushing it through a machine learning model to identify patterns that you didn't know about. For example, is there some behavioral or side effect associated with a drug in one particular geography versus another? Is a certain demographic, for example, that relates to as an example. But the technologies underneath that type of operational AI model are fairly varied, but also at the same time well known. So you may have heard of TensorFlow, that Spark, Scala is another one. You may have heard of Spring AI as well. Python, obviously, a lot of people know from a security perspective, it's very good at has been very good for a lot of people to get used to AI-based construction on around models. But at scale, the big technology that's underpinning a lot of these is Java. So Sparks and Java, centralized Java. So what you find is that the underpinning technology that people need to think about in terms of performance and how to grow these AI models, particularly if the learning model is big and the context is large, is pretty significant. Now, if we sort of double click into Java a second, why is this super important? Because Java itself has been around a long time. It's been 30 years. At Azure, we're experts in Java, and we spent a lot of time just creating solutions, not just to provide alternative licensing or greater intelligence around what's going on in the Java estate, but also high performance. And that's very much needed in the AI world right now. What also is unique about Java is one of the few languages you can just lift and shift what you've been building in what framework and put it into a high performance environment. So that's called a virtual machine, and Java runs inside the virtual machine. So for example, at Azure, we have one of the world's only high performance Java virtual machines, and therefore we can get somewhere between 30 and 55% performance improvement of particular types of Java workload, depending on the application and so on. Now, this particular webinar today isn't designed to get into all of that detail, but just to highlight the fact that when you look at AI at scale, you can't just look at it in a vacuum of the output or just basically the type of data that you're trying to train it with. You have to look at the scale. How much is this thing going to grow by? How much data am I going to need to ingest? What sort of infrastructure do I need? And then if you're running a fairly inefficient, or even if you're running an efficient compute environment for an AI model, then it's power and cooling and data center space and storage and cost and licensing and so on. So we know a lot about this at Azure, and the reason why is because we've been in this space for over 25 years, and therefore we survey and we understand both from an ITAM and a Java expertise perspective what's going on. And a very good example of where we've done that recently is we've asked a lot of people every 2 years what's going on with Java and what's the most important thing that they care about with Java. And this is sort of what they said. And this is designed to be a bit like family feuds in the US, but also about sort of like family fortunes in the Europe, for example. The number one answer they said around what's going on with Java is they pay for support. So that's the biggest issue right now. So whether they're using it for AI and it's grown out of control, or they've got a very narrow use of Java, or basically Oracle's coming along and changing their licensing rules for them, which is causing a lot of concern for them in an employee model, they're paying for support, they've got some concern. Second big area is they're worried about growth, particularly around AI. So Spark, as you'll see in a minute, is a popular type of technology, but particularly it's used underpinned a lot of AI sort of work, particularly transformative AI. So this is when people are getting into that narrow space, moving data around, things like that. Therefore, it grows fairly dramatically. They're also concerned about compute. So when people scale out their environments and they grow to maybe accommodate 3 times the volume of e-commerce on Black Friday, for example, in the US or wherever around the world. And the remainder of the year, that compute sits underutilized, but obviously in the one time of the year, it does utilized a lot. So that needs to be optimized. You need to think about that differently. Fourth thing is widely used. By far, Java is used in the business world across the majority of applications. And it's because it's been around for a long time. If you're in a regulated industry like finance, telecommunications, banking, healthcare, anything like that, the majority of your applications are Java based. Fifth thing is obviously a Spark. That ended up being the number one framework. A few years ago, not so much. It would have been sort of like Kafka or Cassandra or something like that. But Spark has shot to the top, probably largely because of AI. And the last one is security. As that famous analogy from the Marvel film goes, with great power comes great responsibility. So if you build this huge model that's got lots of data in it and it's learning and it's developing the right type of insights, then of course more data means more potential risk, more exposure. Therefore, you need to provide the right type of security for that. And that means critical patch updates, really key understanding of the intelligence of your whole Java estate so you can pinpoint with a sort of laser pen exactly where you need to go and apply particular security patches. So this is probably one of the key things. And of course, of this whole stack, and when you start thinking about some of the most popular technologies, there's a few that sort of jump to mind fairly aggressively. And sometimes that really is just the obvious, which is if you look inside this framework right now, you'll see that maybe the two most important areas, certainly for this presentation, are AI, because that's a high expectation of growth, and the fact that Spark is probably one of the most popular frameworks. So we've taken that in mind. Let's think about, okay, how do we need to think about licensing? Because remember, the topic for this particular session today is ITAM and AI, right? So first things first, how are you licensed? So employee-based licensing is one of the key things that's changed a lot in the Java world. A couple of years ago, Oracle changed their whole infrastructure licensing model to employee. Now, that might sound like, oh, that's probably quite good for AA because I don't have to worry about the infrastructure. I think again, because if your licensing model is based on employee, then that means it's very easy for that organization who's providing you with support and other types of Java updates to just increase cost without having to truly understand what's going on in your environment. So you only have to look and find out, and we'll talk about this with Oracle in a second, what's been going on for the last 10 years, particularly in the Java world. But it's consistently costing more and more, particularly with Oracle. And there's a reason for that. We'll talk about that in a second. We touched on large AI projects. AI projects generally aren't small. It's always a compromise between data, context, and what you expect as an output, for example. You may have heard of a terminology around AI where you get a lot of AI models that just don't produce results and don't produce what they're supposed to do. And that's largely because either the context was too big, in other words, you plowed too much metadata in there and gave it too many things to think about. So, or there's too much data and the whole thing bloats, and then therefore you can't get through the data and then the machine learning can't run fast enough. So large-scale AI projects generate huge cost footprints, never mind the infrastructure and the hardware that's needed. And then complexity. As you start to build in additional models into your AI, and just a very good example is if it's very popular now to think about what's called agent-based models for AI, which is you start small context, break it down, simple task, and then you assemble more agents together and then roll them up into other agents. And a good example I just saw recently was very much the idea of a travel agency. So a travel agency, you want to plan a holiday. However, you don't need to build one big model to do all your holiday planning. You can build smaller AI models that give you recommendations. You could have a flight module, you could have a hotel module, you could have a transportation module, you could have a restaurant module, things like that. And then all of them come together based on the characteristics that you're asking for to give you a recommendation around what the best holiday would look like. That increases complexity. You need to think about it, but obviously different licensing. So what makes this equally more challenging is Oracle. So Oracle, Sun Microsystems was sort of really responsible for Java for a very long time, and then Oracle gained those rights around 2010. And since then, what used to be free has now been monetized fairly aggressively. And that really culminated 2 years ago with the licensing change from Oracle, which basically has turned it for Oracle into something like a $2 to $3 billion industry. And it's only going to get worse. Now, that means that you have to think very hard about which vendors you want to work with. But Oracle's not the only option. Azure is probably the number 2 in the world, and we're significantly cheaper. But we also provide high performance solution for Java, so you can get multiple benefits in other areas, and also intelligence. So you know exactly what's going on with Java everywhere, so you control it and manage it more effectively, including where your security vulnerabilities are. So you sort of have to think about these multiple facets now. It's not just about, I just need to pay for licensing. It's what do I want to get out of this 2-3 years from now? Do I want a high performance solution? Do I want the intelligence? And this is backed up by a lot of research. So when we did the last ITAM specific research drilling into why people are concerned right now, of course, we know a lot of people are concerned. 24% extremely concerned, 32% very concerned, and 28% somewhat concerned. So if you roll all that concern together, that's almost like nearly 80% of everybody, right? In fact, it's 82%. But with that sort of reliance on infrastructure, which is almost 100%, and 66 paying for some form of support right now, with uncontrolled growth and uncontrolled understanding of where your Java is, you could have a bit of a challenge. This is why 72% of everybody are looking for alternative solutions, not just for licensing, for other different areas of value add in and around the licensing, legacy Java support, so they don't have to upgrade and have cost there, modernization support around performance, and intelligence support, understand where my Java is being used, where it isn't being used, where my vulnerabilities are, where I can get rid of code that hasn't changed for the last 10 years and reduce my licensing requirements. things like that, very significant. And of course, the sort of story goes on quite a bit as well, because the ongoing audit situation isn't, it's a challenge if you stay with people like Oracle, because people are concerned that, at some point they'll get audited again and the licensing model will change, and then they'll end up paying huge amounts of money. But that isn't the only issue right now. Licensing and cost management is number two. Number one is security. So this just underpins how much Java is used everywhere, and whether it's in AI and how much of that data comes together. Think about a denial of service attack for a very large AI environment, and then an exploit coming in to take advantage of all of this customer data and all of the insights and the intelligence around that. Very powerful data. You want to protect that fairly significantly. So you need Java that's a solution, or a Java vendor that's going to help you do that, and the intelligence around it. But it's also managing scale, managing performance, as we discussed. So all of these things are equally as important. So in summary, though, and behind me is a little icon here, but also you're going to see a download link in a minute. We've got a great playbook at Azure where you can just go through all of the challenges you face around Java licensing, the type of solutions, what type of intelligence you need. We have a massive ecosystem of partners that can help you in this area. We can help you through what is it you need to look for, both now and for the next few years. Not just, I need to solve my Oracle licensing issue right now. Really, what do I need, and why is this a broader perspective on Java important? And then build the ROI, go with the right solution, and understand why. So a very good playbook for this. It's a completely sort of independent approach, although of course we wrote it. But at the same time, download a copy and see what you think of it as well. So here's a quick download link. Now, outside of that, just in summary, thank you very much for joining this webinar today. We're going to be doing a lot more on the topic of AI and Java, and particularly all of these different things in much more depth moving forward, so you can really explore truly what's important to you and how this market is evolving in this area all the time. Java's here to stay in the Java world. It's had a massive resurgence right now. Sorry, I should say Java's here to stay in the AI world. It's had a massive resurgence in the last few years, largely because it's got easier for data scientists to use Java versus something like Python. And because it's used everywhere, obviously people are now flocking to this a lot more because of the potential value combined with other infrastructure licensing it can deliver. So with that, not sure if we have any more questions, Stephanie. I don't think we do. Okay, I'm going to thank you for your time. Thank you so much. And I'll catch you on the next webinar soon. Thank you very much.